Now we're going to look at another case of given information for a triangle utilizing the law of sines. And the problem with today's situation is going to be that there are actually multiple possible triangles that could be created out of this, so we call this the ambiguous case. So yesterday we talked about the angle side and angle cases, and those are pretty simple to set up using the law of sines, where as long as you have two of the angles and one side, there's only one possible triangle that could be created out of the given information. The problem comes in when you're given two of the sides of an angle instead, so we call this SSA. Basically there will be three different cases. One of the cases is that when you're going through your solutions and you're setting up your law of sines, you're going to end up in a situation where you have sine of x set equal to something. If that number that you're setting it equal to is greater than 1, then no triangle can be made out of the given information and you're done. There's no triangle possible. If you can find the missing angle, so if you end up with sine of x is equal to something less than or equal to 1, so you should be able to get a solution using law of sines, then you're going to want to subtract that angle from 180. And this is where it's going to split into either one or two possible triangles. If you can subtract the angle you found from 180 and still make a triangle out of that other measurement as well, then there will be two triangles to solve for. If you take the angle you found using law of sines and subtracting it from 180 makes the angle measurements add up to something greater than 180 degrees, then you cannot make a second triangle out of that one. So I'll try to demonstrate all of these. I know it's going to sound weird until you actually see it in action. So here's the first case, and the reason we have to be careful about the ambiguous case is because I have one angle and two sides given to me. So we're going to start off by setting up our law of sines relationship. So I'm going to say sine of 61 degrees, and then the side tied to angle A is 8, and I'm going to set that equal to sine of B over 21. Next, we would cross multiply this and get 21 sine of 61 degrees. And we would set that equal to 8 times sine of B. Now, if you actually put these values into your calculator, 21 times sine of 61 degrees, and then you divide that by 8, you should get a value of 2.3, which is supposed to equal sine of B. And then you would be using sine inverse on your calculator to find the answer for where you get that y value. But this number right here, I have sine of B is equal to something bigger than 1. So that's what I'm referring to in this first case. I have sine of an angle set to something bigger than 1, so no triangle can be made out of this information. This one's impossible, so there is no triangle. This is the easiest possible case. This one will require the least work because you get to stop before you even have to go through finding all of the other values. Next situation, same thing. I have one angle and two sides. So I'm going to have to go through setting up law of sines again. I'm going to have sine of 26.3 over side A. And we don't know what angle B is, but we do know that the side is 6. So cross multiply again. And if you're plugging this into your calculator, 6 times sine of 26.3 divided by 7. Now, I will point out that I'm getting a number like 0.3798, etc. Don't actually round this number off. You want to be as precise as possible. So I'm just doing that to write down so you can kind of check with your own calculator that I'm getting something approximately equal to 0.3798. What I actually want to do is find what angle creates this y coordinate. So this is where I hit second, and I use the sine to the -1 function on my calculator. And then instead of just typing in 0.3798, hopefully your calculator has a way for you to input the previous answer that it computed. So for mine, I'm hitting second and then the negative key, and that will input the previous answer. So I'm getting B is equal to approximately 22.3 degrees. If you do it a different way, then you're probably going to end up rounding off too much of your answer, and you might end up with a different degree measurement there. So at this point, I have found one missing angle. Now let's look back at what the next potential cases are from the earlier listed rules. So we did find a missing angle using law of sines. What we're going to do next is subtract that angle from 180 and see what happens. We're going to see if we can make two triangles out of this, or if there will only be one possible triangle. So let me set up what the other one would be. I would be saying 180 degrees minus the 22.3 that we just found. And that's giving me 157.7. So then the question is, can I make a triangle using this angle? What if this was angle B? So I'm going to call it B2, and then we're going to call the other one B1 actually. So can I have angle B2 equal to 157.7 degrees? Well, for that to work, that would mean I have to be able to take that angle plus the given angle, and they would have to be less than 180. So 157.7 plus 26.3 is equal to 184 degrees. So here's where the problem's coming in for us. If two of the angles, the angle they gave me and then the other potential angle for angle B, if those two add up to be 184 degrees, then I can't have a third angle in the triangle and make them add up to 180. We've already gone past the given allotment for the sum of the angles in a triangle. So basically, I don't have to worry about this second case. There is no second triangle in the situation because the math just doesn't make sense. It doesn't work. So what we can do instead is we can keep focusing on our first triangle here. We know two of the angles now, and we're going to find the third angle, angle C, by doing 180 minus the one we were given minus the one we found. And that's going to equal 131.4 degrees. So now we know all three angles, angle A, angle B, angle C. We know side A and side B, but we still need to find side C. So I'm going to find that using law of sines again. I'm going to set sine of 26.3 over 7 equal to sine of 131.4 over side C. So cross multiply. And if you're putting this into your calculator, 7 times the sine of 131.4 and divide that by sine of 26.3, I'm getting side C is approximately 11.9. So now we have all of the values of the triangle. We have the three that they gave us and then the other three that we found. So it does help. You might want to make a habit of circling them so that it's easy to identify your answers. And that way you'll also know when you're done if you've found everything that you need. So this was the case where it was not possible to make a second triangle out of what we started with. And then in our last example here, again, you're not going to be able to tell that there's anything weird happening just from looking at the given numbers. So we're still just setting up the law of sines. I'm going to have sine of 30 degrees over 6. And then we don't know what angle B is. So we're going to cross multiply. Now, since sine of 30 is actually one of the angles on our unit circle, you can actually compute this one much more precisely rather than using a decimal answer. And you should be getting that sine of b is equal to 7/12, or in decimal form, it would be 0.58333 repeating. And then when you're taking sine inverse of that angle, make sure that you, again, don't round it, use the exact value from the previous answer. You should be getting that angle b is equal to 35.7 degrees. Now again, I'm going to call this angle B1 for a second because there's another possible value for angle B. So we're going to try and compute that one real quick. B2, the second possible triangle we can make out of this, would instead be 180 minus that angle. Which gives us 144.3. So assuming this is a second possible angle B for a second, then we would need to see what angle C would be in this case, which would be the 180 degrees that come from a normal triangle minus the 2 that we know. So we have an angle of 30. And we're saying 144.3 would be the second angle in the triangle. Which would give a value of 5.7 for the third triangle. So in this case, we are getting a reasonable number. We are getting a number that can actually work for the second triangle. So unfortunately, that means we're going to have to go through the law of sines process twice for these. So it doesn't really matter what order you're doing these in. So let's go ahead and finish the first one we were setting up before we move on to the second triangle. So we found that angle A is 30, angle B is 35.7 for this one that I have in blue. And then we still need to find angle C. So I'm going to call this C1 now. The reason I'm using the subscripts here is because I need to differentiate between the values from the first triangle from the values for the second triangle. The values that they gave us originally, those will be true in both of them. So angle A is 30 for both triangles. Side A is 6 for both triangles. Side B is 7 for both triangles. But now we have, for the first triangle only, side B equals 35.7, and for the second triangle, it's 144.3. We found side C for the second triangle, but we haven't found it for the first triangle, so that's what I'm indicating here with the subscript of 1. That's going to come from 180 minus the side A of 30 minus side B, and you have to be careful and make sure you're not switching your values around. You have to make sure you're using the B from this triangle and not accidentally using the one from the other triangle, or your answers will start to get switched around. So 180 minus 30 minus 35.7 gives us a missing side, or sorry, a missing angle of 114.3 degrees. And then we still need to find the missing side C, so we'll have sine of 30 over 6 equals sine of 114.3. over side C. And then if you cross multiply this one, it's repetitive work. It does take a while just to get the answers, especially when you have multiple triangles that you have to go through. It's unfortunate. And then by plugging this one in the calculator, 6 times sine of 114.3 divided by sine of 30 is giving an answer of 7.0. And again, I need to specify that that's side C1. So now we have the 3 missing values for triangle 1, but we still have to finish a little bit more for triangle 2. So for triangle 2, we know all 3 angles, angle A, angle B, and angle C. We know side A and side B, but we still need side C. So now it's the lowercase c2. And so again, it's going to come from setting up another law of sines. So sine of 30 over 6 set equal to sine of 5.7 over C. When you evaluate this one, 6 times sine of 5.7 and divide it by sine of 30, I got the final answer of 1.2. So again, be careful in your distinguishing between the two triangles. Make sure that you are getting 6 values for each of them. You should have 3 angles and 3 sides for both triangles when you get to the end. I'll try to go over what causes the two triangle situation in class. It's something that would be a little bit easier for me to demonstrate on the board rather than trying to do this on a video. So that's all for the notes. Thank you.